Hey everyone, welcome to this session called Breaking Through the EDA Productivity Barrier, Exposing Secure, Reliable Event API Products. My name is Hakansson, and I'm the VP of Product at a company called Gravitee. So what I will be taking you through in this session is discussing a little bit about event brokers, and consuming events. I will then introduce some of the challenges around event APIs and what I mean by treating event APIs as first-class citizen. We'll then review a sample use case where we want to build a social media services using events and APIs and allow internal and external consumers to work with those events. We'll then have a look at Solace and Gravitee coming together to help exposing secure and reliable event API products. And then I'll introduce the term of event native API management. So eventing a service or a backend is the start of something beautiful often. Obviously, Solace is one of the companies that help organizations by doing this. And it allows for new revenue streams. It allows for new kind of consumer models, and it allows for taking more real-time decisions and delivering better user experiences. Now, when you expose events, consumers, especially external ones, typically have quite high expectations. You might talk about different protocols, not only your AMQPs and MQTTs, but you might also talk about webhook and REST and server-side event and webhooks and so forth. And one of the challenges with exposing events that, sure, exposing them internally and securing them and so forth has its own set of challenges. But in terms of exposing them externally and building maybe partner revenue streams on top of them, it's not always very easy. It might be difficult to govern. It might be difficult to deliver all the requirements that end users might have, such as self-service documentation, being able to view things in a portal or a catalog, accessing and getting permissions to use certain events and event API products. Sometimes it's tricky when you have users that sit outside of your perimeter and firewall that wants to consume or produce into your services. And in some cases, you may want to protect your services with things like OAuth or certificates, or maybe with throughput limiting or quota or different type of traffic shaping to further control the behavior of how your events are being consumed and produced. And one important thing to take into consideration is that different consumers and producers, depending on their maturity in terms of technology, where they sit in terms of a security posture, and what their actual use case is, might require different types of protocols in the way that they talk to the applications. So what Solace and Gravitee is doing to help solve this problem is having Solace as the back burner of the event-driven architecture, helping organizations designing and creating those events in things like the event portal, and then exposing them using things like async APIs. What Gravitee is doing is allowing those events to be automatically exposed in developer portals, giving API consumers and API owners the same type of experience that people are typically accustomed to when it comes to REST APIs and Open API specification, where we talk about self-service discovery, application management, alerting, monitoring, and obviously the entire life cycle around the access and control of those events and APIs. And what Gravitee also do is applies traffic shaping that you would be accustomed to with rate limiting and transformation and payload examination from a security perspective, for example, on the messages that go through a particular stream. And Gravitee also helps with mediating through different protocols. So on the right-hand side here, you could see that we might have consumers that prefer to talk to event-driven architectures using other protocols than just your Solace message formats or MQTT, AMQP, Kafka, and so forth. And it might be things like REST APIs, maybe using HTTP posts to ingest data into a topic or a queue, or maybe receiving data asynchronously using things like webhook whenever there's a change in an underlying service. And protocol mediation helps to translate in the best way possible so that API owners can be in control of how their API consumers are getting access to the right data. So let's have a look at an example use case. So in this particular case, I want to build a social media service. So some of my services that may want to consume or produce events to communicate with different services and their own services might be, for example, a recommendation engine to give the right suggestions, maybe for the right friends or for interesting content on this social media service. I might have an ad service that might be also working with my partners and other kind of ERP and CRM solutions potentially that are interested in things happening in the platform. And I might, of course, have a profile service where I might look into the user information, how they operate, how they have decided to control their information in their exposed profile. And of course, those might be talking to an event broker to really help with decoupling those services and get them to get the right data that they are interested in the right time to deliver as a quick and real-time service as possible. And this is, of course, where things like Solace come into play to help with this, to create an event mesh across different landscapes and different architectures to connect services through a broker. So what happens when you have certain consumer-oriented applications that need to interact with this data in some capacity? You might have a mobile app where the user is signing in from. You might have a web server that needs to be notified. Maybe it's a partner web server or something sitting outside of your event mesh that needs to receive information whenever a user is signing out of the platform. And you maybe want to stream information in a website or so forth in real time to monitor the activity on user posts. Maybe people are liking information, and you may want to stream that in an asynchronous fashion so that the user gets immediate input on someone, for example, has liked their comment or their post. So how do you do that? So in this particular example, we might have people that are using maybe a mobile app to sign into a website, and that might, of course, generate an HTTP post request that is trying to authenticate to an identity provider potentially. Our server might be using things like webhook to register a callback URL and receive information asynchronously whenever there's a user sign out event happening on the platform. And some might establish persistent web asynchronous technologies like server-sent events and WebSockets, for example, to be able to have either a unidirectional or bidirectional communication between a client interface and a server of some sort. So one way to help with this and really bridge the gap between event brokers and consumer protocols and web application is an API gateway. So what an API gateway in this case would do is it would sit in front of an event broker and help translate between the native asynchronous streaming protocols like AMQP, MQTT, Kafka, SMF, and so forth to more web and sometimes client-friendly interfaces like HTTP, webhook, WebSocket, server-sent event, and so forth. It also, of course, helps with things like maybe applying rate limiting and topic routing and other logic to help drive user experiences and build new applications on top of events. What I will be going through here is how we could potentially use Solace and Gravitee to help cater for this use case. So I would be using Solace here to create an event API product. So the terminology in Solace basically goes events, event APIs, and event API products. So events in Solace typically have schemas to determine what is the payload and messages in a particular event. Is it possible to publish to the event, or is it only maybe possible to subscribe to the event? What you can then do is you can group events together into an event API. So in my particular case, I have 3 events. I have a user signed in event, I have a user sign up event, and I have a user like event. And I have 2 event APIs. I've grouped my signed in and signed up event in the user event API. And then I just have a single event API called user like event API, which has my user like event. Now, technically speaking, for those aware of the async API specification, in Solace, your event APIs are effectively treated with individual async API specification file that can be introspected and downloaded. What you can then do is you can create products on top of your event APIs. So in my case, I've created a user event API product that groups my two user event API and my user like event API. And that's kind of what you can see here in the screen of the console event portal, where I have my my user event API product that has these two event APIs that then themselves control two, respectively, one event that has publish and subscribe capabilities activated on all the events except for the user signed event, where we only want to subscribe for information. Then what Gravitee is doing is automatically connecting and listening for particular event API products that have been created by the Solace designer. Whenever a new event API product is created, Gravitee, which is a full lifecycle API management platform for both APIs and event APIs, is identifying a new event API product. It will import it as a new API in Gravitee. It will expose it to a developer portal that then allows users to be able to discover APIs that they have access to view documentation. So in this particular case, what Gravitee is doing is aggregating the different event API documentation into one event API product async API specification, which the user can interact with, view the different payload examples, and understand the different consumption models. You can do a lot of more things with Gravitee on top of your Solace APIs. You can, for example, apply different security mechanisms, whether you want your end users, maybe my mobile app that is posting data into my broker. I want that to have maybe API key protection or OAuth2 protection, or maybe I want to use SAML or other types of authentication. You can then also easily apply quotas or rate limits or other types of restrictions on top of your APIs. And you can do traffic shaping. So on the right-hand side here, we're using what is called a policy studio of Gravitee. And we're saying that when data is coming into the event broker, we're first applying rate limiting, and then maybe we are doing some custom JavaScript in this case to do some maybe lightweight transformations, for example, or validation. And maybe we would be responding with serialized data back to the consumer to keep the performance as good as possible. And what we could do here is maybe transform the data from maybe Avro to JSON, for instance. So there's a tons of capabilities that we could be using, everything from different security-oriented applications or transforming data in different shapes or forms, or indeed calling out to other third-party services as part of a particular publish and subscribe operation. Now, as an API owner, having had that Solace Event API product imported and controlled into my platform, I can then allow my end users to go through the developer portal, discover the APIs, view the documentation, and then register their applications for subscriptions to these APIs. So in this particular case, on the left-hand side, you can see that my API has a API key listener and a subscription type of plan that allows different types of consumers to consume the APIs with different authentication mechanisms. For example, for my HTTP post client, I might be allowing an API key authentication. And for my subscription, which might be over webhook callbacks, for example, I might not need any authentication. It's just going to need an approval by the API owner before I get the events sent to my particular server application. Then, of course, it's up to the API owner in the administrative console to go through and review any application requests to my event API product. So technically speaking, how this works, whenever I'm invoking one of those APIs I have subscribed to. So if I'm building a mobile app, I might use a REST API to call the API gateway to maybe with a payload of the information about the user sign-in. The API gateway will then talk natively using the Solace SMF protocol to a Solace event broker. And then the Solace event broker, of course, is allowing different types of subscribers within the event mesh to listen for certain topics or queues or whatever it might be. On the other way around, where we have maybe a webhook use case where we want to send information to a web server whenever a user is signing out, we might be, which by the way might be created maybe by the profile service. The gateway in this case will actually listen for changes to particular topics or queues in the Solace event broker. And whenever that happens, if a filter applies and the subscriber has subscribed, it will then send webhooks using HTTP post to the right consumers that are subscribing to this API. And the third use case here is we can establish asynchronous persistent connections using WebSockets and server-sent events and other technologies that is then bridged to the Solace event broker and producing or consuming from the right topics and queues. And again, you'd have the ability in this particular case to allow for message transformations and quota limiting and other enforcements on the individual messages on those streams. So that's quickly going through some of the use cases and technical implications of having a solution that can deal with both synchronous and asynchronous means of consumption. What I wanted to quickly walk through is how we at Gravitee have seen API platforms evolve and how that is impacting event-driven architecture and new ways of consuming and producing messages. So the way we see the world is that API 1.0 was the first generation of API platforms that looked to address a series of challenges that arose when organizations starting to have a lot of services and moving to cloud and having different data centers and needing to connect and communicate with those services. Sometimes they needed to expose services to third parties. Sometimes they needed to ensure they had protection, documentation, and other means of centralizing control for their APIs. And this is where the first generation of API platforms look to address those sort of problems. What we then started seeing a couple of years ago is organizations breaking up their architecture, typically taking a monolith implementation and breaking up into smaller, more lightweight microservices. You had a rise of containerization and Docker. You had things like Kubernetes for managing microservices and orchestrating microservices being a norm of how organizations deploy applications. And this drove a new set of requirements on API platforms. No longer were you only needed to ensure that you provided governance on top of APIs. You needed also to do it in a cloud native and Kubernetes native way, allowing things like ingress and Kubernetes operators and service mesh use cases, and being able to work in a more declarative and infrastructure as code-oriented way. What we here at Gravitee have seen over the last 4 or 5 years is a new set of requirements being driven very much from the adoption of event-driven architecture. So event-driven architecture is obviously very much booming. People want to deliver more real-time experiences. They want to take real-time decisions. They want to have access to real-time data to deliver better experiences and to help drive new revenue streams. When you do that, you implement technologies typically like a Solace, like a Kafka, MQTT, AMQP, the different Azure, Amazon, Google, and technologies and so forth. And eventually, what we are seeing is that people end up with the same type of challenges that they used to have for traditional REST API or SOAP APIs that the 1 and 2 first generation of API platforms look to address. So how do I document my event APIs? How do I secure them? How do I put traffic shaping on top of them? How do I control access to them? How do I mediate control in terms of the protocols that are being used? So what we are seeing is organizations wanting to apply the same type of capabilities to productionize, monetize, and control both traditional APIs and event APIs with a single set of tools, with a single set of practices. And that is what we believe that the next generation of API platforms are looking to address. So at Gravitee, we have coined the term event native and event native API management. And let me just walk through what we mean by that. So with event native, we mean having the mindset and capabilities to treat event-driven architectures and event APIs as a first-class citizen in a full lifecycle API management world. So we mean all the way from the inner workings of a gateway runtime to be able to understand Kafka, MQTT, Solace, and other event brokers and protocols, being able to not only act as a reverse proxy and forward messages to an upstream service, but also think the other way around, being reactive and listening to changes happening in brokers and then taking actions, for example, sending HTTP messages to webhook subscribers. We mean the ability for API platforms to also allow traffic shaping and transformations on not only the request and response phases of APIs, but also on the publish and subscribe individual messages that are pushed through in the stream. We also mean the ability for API owners to document APIs and work with event type of standards like the async API specification and the cloud event specification, for example, in a similar fashion as they've typically used things like Whistle and OpenAPI and Swagger and those sort of technologies. We also mean the control for API owners, not only to mediate between SOAP and REST or GraphQL, but also give flexibility to expose your APIs, whether it's a Solace or Kafka queue or topic, using a flexibility of protocols, like we covered in our use cases, ability to use REST on top of your Solace, ability to use WebSockets and webhooks and server-sent events and other asynchronous protocols that are still capable of being implemented in web applications and sometimes more easily consumed or produced from third-party or internal applications. So that's a little bit of Gravitee, Solace, and how Gravitee and Solace works together to unify both traditional APIs and event APIs and event API products in a consistent fashion with a single set of tools for discovering APIs, subscribing to APIs, and consuming APIs, as well as the ability to extend Solace events using a flexibility of protocols. So that's all I had. Thanks so much for attending this session, and don't hesitate to reach out if you have any questions on how Solace and Gravitee work together, or if you want to have a quick demonstration or more insight on what event native API management brings. Thank you so much.